Good morning, everyone. Today we will be doing an overview of the article Blockchain-based multi-signature approach for supply chain governance, a use case from the Australian beef industry. My name is Carol Yunus and I'll be graduating in spring 2024. I work as a software developer and also as a machine learning engineer in India. I am an NLP and an AI enthusiast, and some of my hobbies are yoga, gymming, writing poetry, and reading books. And that's my cat, who is my sidekick, but he sadly passed away. So yeah, come on, Praveen, introduce yourself.
Hi everyone, this is Praveen. I'll be completing my master's in spring 2024, and back in India I have an experience of 3 years as a backend developer. Coming to my technical interests, I like to dig deep into databases and get to understand systems like at a scalable level, and I like to build products and I like to code, and other than that I like to play badminton and watch Netflix on the weekend.
A few years ago, China Walmart was involved in a pork scandal. So in a city in China, Walmarts were asked to close down and also were asked to pay a fine of around $420,000 following an investigation into the mislabeling of regular pork as organic. But now in recent years, blockchain technology can be used to improve food safety. And now consumers can scan a tracing code to get information about the product. Now we'll be doing an in-depth case study of the beef industry in Australia and not pork. So our story starts in Queensland in Australia, and the meat trader works with geographically dispersed supply chain partners, and this entire process where the logistic transport takes around 85 days for the cattle to come from the farm to the stores, where they spend 70 days in the feedlot. And in this particular aspect, I'll be talking about supply chain governance, the digital transformation of supply chain governance, and blockchain enabled supply chain governance pertaining to this use case in the subsequent slides. Next slide, please. So as I have given an overview of the meat trader involved with these 4 stages: production, feedlot, processing, and food services, we'll be going in depth into the use case design. The first phase is the requirement analysis phase, where interviews and discussions were held and on-site observations were held, and then some pain points were discovered. And some of these pain points were dyadic relationships, supply chain partners being geographically dispersed, and lack of technical capabilities in firms, and interfirm capabilities were sorely lacking. So taking these pain points into consideration, the prototype was designed, and which brings us to the next phase. As you can see to your right, this is the multi-signature enabled supply chain architecture. And you can see that it comprises of 2 parts, that is a multi-signature data registry and a tracker. And you have supply chain actors who act both as a proposer and as a validator. And you have 7 key processes in this supply chain, and they are registering livestock at the farm, and then it is delivering livestock to the feedlot, then it is completion of the livestock at the feedlot, then delivering the livestock to the abattoir. Abattoir is nothing but where they butcher the meat, and feedlot is nothing but where they fatten up the cattle. And in the next stage, they create portion cuts at the abattoir, and then they transport these portion cuts to various food services, and then the food services receive these portion cuts accordingly. Next slide, please. This brings us to the next stage of the use case design, which is the finalized design and development. And towards your right, you can see that this is the final proposed architecture where this particular use case talks about the protocol design for this multi-signature feature. And as you can see that I have just briefly given an overview of the 7 stages that are involved in this particular use case, and we will be talking in depth about the architecture. So you have layer 1 here, which the main core component of this layer 1 is a multi-signature data validation protocol. And in the layer 2, we will be talking about data block generation and storage layer as well. And then we'll be talking about the beef supply chain events. Here, and the first event here is the produce event, where where the users are going to register their assets. Now, when the livestock is picked up and relocated, subsequently pickup and drop off events are registered. So these transactions which are registered to the blockchain, when they are registered, a transaction hash is produced. Now users have an option of minting a unique digital certificate. And then we come to the multi-signature groups. Now these groups can be the network as a whole, or it could just be some subsets of the observers. Now this particular use case was based on smart trade networks. Smart trade networks is actually a type of blockchain platform, and this STN platform is a proof of authority based network operating on an Ethereum virtual machine. Now you have data which is a five-dimensional data here, and this has been used to improve the data quality for this particular use case. Now also we can see that a user interface was developed. Here as you can see, actions such as tracking your assets, registering livestock, adding members, removing members, all of these are multi-signature actions, and even this comes under finalized design and development. Now the last stage is evaluation and analysis, where all of these features that I've just briefly spoken about are integrated into the system, and this has been shown to increase the system's performance. And 7 benchmark criteria were also discussed in this particular phase. Some of them include performance, privacy, assurance, relevance to stakeholders, operational capacities, considerations, and feasibility. Now the rest of the presentation would be handed over to my colleague Praveen.
Yeah, first of all, thanks Carol for explaining everything about the architecture in detail. Now we will go through the use case and how the real-time data has been captured and how it has been used for the future scope. So the entire process has the 4 different stages, which are like the production phase and the fattening phase, the processing phase, and food services phase. Every phase they are collecting some real-time data, like from feeding the cattle and from farmers to the meat traders, like how they are grown and how they have been, like at what weight they have been processed and how they are cut in different portions and how they are being supplied to markets. And as they are collecting data at every stage, the author has divided the data into 5 different dimensions. The 5 different dimensions are the product, period, place, price, and people. So every data dimension gives an important role here. Like for suppose if you want to get data related to a particular period of time, like during Christmas sale, Christmas time, how much meat is being supplied to a particular location. So at this point of time, we can use the place dimension and period dimension. In the same way, we can use other dimensions like product dimensions and price dimension, people dimension. Now, as we are collecting different sets of data in like huge amounts, we have to ensure the integrity of data. So in order to ensure the integrity of the data, the author has introduced a new concept, the magic link concept. The magic link concept is very interesting. It helps us to log into the system like in a really faster and highly secure way. So if you see here, the magic link concept is like, first of all, you will enter the email in the portal, and then it generates its token. So when it generates the token, it will create a hash table in the system, like for suppose my mail ID is praveen@gmail.com, it will append the token to my email ID. So once the token is generated, it will create a hyperlink, which is nothing but the magic link, which will be sent to the email ID. So once you click on the email ID, it will validate the token which was sent via the link, which was in encrypted format with the hash table. Once the token is validated, it will give the access to the the portal in a very faster and secure way. The important thing about magic links are these are like one-time use, just like OTPs, and these can be like time frame. Like after a certain point of time, you have to relog in again. So this way, every time you have to do some CRUD operations like create or read or update or delete operations, anything related to data at every stage. You have to log into the system without login ID and password. So this cannot be hacked easily. So this way it can be like highly secured. Coming to the next slide. Yeah, let's. While the author has created this article, they have faced certain limitations, particularly the scalability issue and security and privacy, because we are getting into huge data here. Right now, author has done a pilot study only with a one meat trader. What if there are like millions of meat traders and millions of requests coming onto the server, and how the server can handle such amount of requests, like millions of requests coming at a particular second, how the load can be handled. So this was not studied so far. So scalability is a big issue, and coming to security and privacy issue, as we are having huge amount of user data as well as the products data, like we need to make sure the privacy and security is very high, but the author has not done it clearly because he has done only with one meat trader. However, this approach will be like heavily effective in terms of traceability, transparency, and accountability, because as you can see, at every stage there is a set of data and everything is tracked clearly in a real time. So we can clearly get everything like in clearly traceable way and transparency and accountability. And coming to our idea to extend this approach which author has published, so we can use smart contracts here in order to ensure like how can you qualify set the quality of the product, like the meat product. For suppose if we have certain temperature or certain portion of size, this can be predefined qualities which we can keep, and we can certify the product in an easy way using smart contracts. And coming to dynamic pricing mechanism, the dynamic pricing mechanism will be like really good in terms of two different ways. It will generate good revenue to the entire process, and as well as to give incentives to everyone, from farmers to the meat traders, everyone in an equal way. Let's say for example, to generate good revenue, how it can be used. For suppose in Long Beach during Christmas time, the meat will be sold like heavily, but the supply is very low and the demand is very high. At this point of time, they can easily increase the prices and generate good revenue out of it. For suppose if in Fullerton the supply is high but the demand is low, so what they can do is they can reduce the prices and get the initial cost what they have kept. So this way they can get good revenue, and they'll not be going into losses with the help of the real-time data. And if we integrate AI and IoT, we can make everything automated. And if we introduce a smart packaging concept, for suppose if we have IoT sensors introduced to the smart packaging, we can track the temperature of the products at any given point of time, and we can know like how the products are being spoiled at what temperature and how they are being maintained in a good way. And this way we can keep the products not stale for a long time. And this way we can conclude, and we can that our ideas can help us to get good revenue to the process, as well as handle the data in a highly secure way. That's it. These are the differences we have used, and if you have any queries, shoot out.
Very good, thank you. Next theme.